Okay, morning 9p. We are starting Unit 8 today, which is very exciting because it means we get to learn about Pythagoras' theorem, which is very exciting and very, very useful. Now this first bit here you will be able to do by yourself, so I'll not be filling this in, but I do want you to spend some time doing it. So on squared paper, so just in your classwork book will do, draw 6 right-angled triangles accurately. Okay, so right angle triangle means that one of the corners of your triangle has to be a right angle, it has to be 90 degrees. Then measure all 3 sides and record what you find in this table. So in your triangle you're going to have a shortest side, a middle side, and you're also going to have the side opposite the right angle. It's always going to be the longest side. Okay, so if you look at the titles in this table, we've got the shortest side, but you don't just record the size of the shortest side. I want you to record the size of the shortest side squared. I can nearly say that. So say your shortest side was 3 centimeters, then you would record 3 squared in there, which is 9. Say your middle side was 4 centimeters, then you would record what 4 squared is in here, and that's going to be 16. And then you would do the same over here. Now because you're just drawing random triangles, they're probably not going to be exactly 3 and 4 and 5 and 6 and 7 centimeters. So don't forget you can use your calculator to square. So if one of your sides is like 3.4 centimeters, use your calculator to square that. The whole purpose of this is just to see the relationship between these 3 things. Okay, so pause the video now and do that for 6 triangles. Okay, now if I had done that one that I was talking about there, so say I had a triangle which had a side of 3 centimeters and 4 centimeters, this side here would have been 5 centimeters. Okay, so if you want to try and draw that one out, and you will find that that's the case. And if we look at these whenever they're squared, so 3 was our shortest side, squared give us 9, 4 was our middle one, squared give us 16, and this side whenever you measured it would have been 5 centimeters, squared is 25. Now see if you look at this, 9 plus 16 equals 25. I want you to check that for all of your other ones in your table, and you should find that that has worked every single time. It might be slightly out because you're maybe like a millimeter or 2 out whenever you're measuring your sides, or maybe your right angle wasn't a perfect right angle or something like that, but roughly speaking, you should have found that the number in this one plus the number of this one give you the number in this one. Isn't that cool? It is. Don't try and pretend it's not. It is. It's very cool. So what you have just discovered is down at the bottom here on page 76 is Pythagoras' theorem. So this is what Pythagoras' theorem written out looks like. So it means, or it states, in a right angle triangle, so that's very important, this only applies to right angle triangles. So in a right angle triangle, the square of the hypotenuse, ooh, fancy word, isn't it? How fancy are we going to sound saying that? I'll talk to you about what side that is in a second. The square of the hypotenuse is equal to the sum, which just means add up, of the squares of the other 2 sides. Now this is one of those things that like sounds really fancy, but it's honestly not as fancy as it sounds. Okay, so say I had a right angle triangle, and I do want you to draw this one into your notes as well, please. So there's my right angle. The side that is opposite the right angle, remember I said just there whenever I was doing that we went up at the top, it's going to be the longest side. It will always be the longest side. This is the hypotenuse. So I do want you to draw that in and label it. Now these other 2, we don't really give them a special name, they're just the other 2 sides. But this one, the one opposite the right angle, is the hypotenuse. So let's write in opposite the right angle, and then we'll know that. And we'll remember it. So that's the side there. So the square of the hypotenuse, so this number here squared, is equal to the sum of the squares of the other 2 sides. That just means if we get the length of this side and square it and add it to this side squared, we'll end up with this side squared. Okay. Now, the way that we actually end up writing that is we write a squared plus b squared equals c squared. Or, if you prefer, we can write c squared equals a squared plus b squared. So different teachers will do that different ways. This first way tends to be my habit, but we might actually find for the first lot of questions that this way is a little bit easier. So we'll see how we go. Now, from this here, so we'll cover this one for now, they're both the same thing, but from this here, the one that's on its own, the C, that is the hypotenuse. So let me just label that one. So this is C. A and B does not matter which way around we label them, honestly, it doesn't matter, but the hypotenuse is always C. And then A and B are the other two sides. So for today's lesson, we're just going to be focusing on finding the length of the hypotenuse, so finding the length of this longest side on the triangle. Okay, so make sure you label these on your triangle as well, so that you know the hypotenuse is always C. Okay, so on to page 77, we've got a couple of examples before we start our classwork. So we have to use Pythagoras' theorem to find the length of the hypotenuse, and remember that's going to be the longest side here of a right angle triangle, and we've got these two to do. So the first step that we need to do whenever we're doing these is to label the triangles, label the sides of the triangle. So here's our right angle, and the side opposite the right angle is the hypotenuse, and if you remember from our equation, we always call it C. A and B do not matter. This one could be A or this one could be A. It does not matter at all. So let's call that one A and that one B. So we've labelled our sides. Then we start off by writing out Pythagoras' theorem. So A squared plus B squared equals C squared. And we would say this or write this every single time. Then all we have to do is replace these with the numbers. So A is 7. So 7 squared plus B is 4 equals C squared. And C is the one we're trying to figure out. It's the hypotenuse. Okay, so 7 squared is 49 plus 4 squared is 16 equals C squared. And 49 plus 16 gives us 65. Now, do you remember in algebra whenever we had to find one letter, we needed to do the opposite of what was happening to it? Well, the opposite of squaring something is to square root it. So I would probably rewrite these the other way around. So C squared equals 65. So going from this line to this line, all I've done is swap sides. Okay, so C squared equals 65. So that means C is going to be equal to the square root of 65. And that is 8.06 if I give that to 3 significant figures. And because these units are centimetres, these units are centimetres too. Okay? Let's look at example 2. So we've got this right angle triangle. And first thing, remember, label our sides. So the side opposite the right angle is side C, and A and B don't matter. So I'll call this one A this time and this one B. Once we've labelled our sides, then we write out our Pythagoras' theorem. So A squared plus B squared equals C squared, and then fill in what we know. So A is this one, it's 12. B is this one, so it's 19. And C is the one we're trying to figure out, so we just leave it as C. So 12 squared is 144. 19 squared, bet you Joseph you could tell me this, is 361 equals C squared. Add those together, so 144 plus 361 gives me 505. So I'm just going to swap sides again just so it's like what we're used to. And then if c squared is 505, we need to take the square root of both sides to find what c is. So the square root of 505 gives us 22.4722, and if I give that to 3 significant figures, that's going to be 22.5 centimetres. Now, one thing I should have said that we could do as a wee check. Do you remember right back at the start I said that the hypotenuse, which we label as C, is always the longest side? Have a wee check. Did your answer for C come out to be longer than these other two? Well then, and like similar enough that it makes sense? Well then you know you're probably on to a winner. So that worked for this one. Let's look back at the first one. 8.06. Yep, a bit longer than these two. So that worked out well. Okay, so I'll list your classwork for you on Google Classroom. Hopefully that made sense, and make sure you ask if you're not sure about anything. Okay, see you next time.